In this video, I'll demonstrate how to find the p-values in a hypothesis test on a TI83 or 84 calculator. We'll go through a few examples to demonstrate this. In the first example, example 1, the story goes that a manufacturer of cereal produces their cereal in boxes labeled 14 ounces. To test if the average weight of all their cereal in boxes is 14 ounces, they sampled 500 boxes. The average of these 500 boxes is 14.1 ounces with a standard deviation of 1.2. Let's test the claim at the 1% significance level. So we're just going to go through like a 3-step process for doing this hypothesis test. Normally I show this as a 4-step process because we have to find the test statistic and then find the p-value from a t-table or z-table if it's a z-test. But we can actually do both of these parts in step 2 immediately on your calculator. But our first step is always to write HO and HA, the null and alternative hypothesis. Since we're just trying to see if the average weight is 14 ounces or isn't 14 ounces, this is a two-tailed test where HA is that mu is not equal to 14. All right, first you're just going to hit stat. And again, all the commands are listed down here, so you can see what I'm pressing, and it's also highlighted in red. And then you're going to right arrow over to tests. The very first option is a z-test, and we can use z-test even though we don't know the population standard deviation because we have a large enough sample where either z-test or t-test will be very close the results for. So z-test is fine. Hit enter. We have two choices. We can either use data or use stats. If you were going to use data, this is if we had the raw data set. So in other words, we didn't have the mean and we didn't have the standard deviation for a sample. All we had was just the raw data of all 500 boxes. So that means we would have to enter in all that data and then go through this procedure. All right, but let's just assume we just have the stats to work with. Mu naught is this mu value under HO. So under HO, we're saying mu is equal to 14. So 14 is our mu naught. So just type in 14. All right, since we're using a z-test here, it wants to know what sigma is. Well, we don't know sigma, but we do know S, and that's an approximation for sigma. So we can do 1.2. Just type that in for sigma. And I do apologize for the lag from my computer. The sample average was given to us as 14.1, so you could just type in 14.1. And our sample size was 500 since we had 500 boxes. Next, you want to select what the HA is, what symbol is under HA. It's either not equal to, less than, or greater than. Since we're doing a not equal to test, make sure not equal to is what's highlighted and hit enter. And you can ignore the color part and then just hit calculate. And you may not even be given that color option depending on which calculator you're using. Okay, and there you go. So this Z over here, this 1.86, that's actually our test statistic. I can write that down. You don't really need to know the test statistic here since we're going to use the alpha p-value approach. But often people want to see this test statistic. So on a test, I might even ask for this. And this we can calculate with our formula as well. The x bar minus mu naught divided by s over square root of n. You can use that formula or you can just use your calculator and it'll give it to you automatically. So where it says p over here, that's actually our p-value. So our p-value is 0.0624. Generally people round this to 4 decimal places, so I'll do that as well. And so our conclusion is just this. Our alpha value is 1%, and our p-value is 0.0624. So that means our alpha value is less than our p-value. So we're going to fail to reject HO. And if this was if we wanted to phrase this a little bit more in the wording of the problem, there'd be insufficient evidence of either to reject HO or to support HA, however you want to phrase this. So there's insufficient evidence at the 1% significance level that, let's see, we wanted to test to see if the average weight of all boxes is 14 ounces. So there's insufficient evidence to reject because that's HO. to reject that the average weight of all cereal boxes, to reject that it's equal to. Okay, and that's our conclusion. There's insufficient evidence to reject HO being just the average weight of all boxes equals 14 ounces. All right, let's do the same thing again, and we're actually going to wind up with the same conclusion. But what happens if, so same sample and same story, but what happens if instead of wanting to test to see if mu equals 14 or doesn't equal 14, we wanted to see if the true mean was more than 14? So we're going to start this off the same way, and we're going to hit stat again. You're going to right arrow over to test, select the very first option, Ttest. And all this information is the same. The only thing we need to change here is this line right here, where it's asking for HA. This time we want to do a right-tail test. We want to see if mu is greater than mu naught. And then you hit calculate. And of course the test statistic is the same as before. So our Z is 1.86, same as before. But now our p-value is 0.0312. All right, so notice here that our p-value now is 0.03, but our p-value before was 0.06. That's not surprising if you think about when we were dealing with the table method. When you had to find the p-value for a two-tail test, you wound up doubling the p-value you would have found for the one-tail test. So that's all that's going on here. The two-tail p-value is just double the one-tail p-value. The important thing to note here, though, is that you don't have to do any doubling or do any kind of weird calculations with the p-values. When you're doing a hypothesis test and you're having the computer or calculator do the numbers for you, it will automatically do any kind of adjustments to the p-value for you. So again, our conclusion is since the alpha value is less than our p-value, just like before, we would fail to reject HO. Okay, let's move on to a new example. Same thing as before, but this time we're going to do a t-test. And again, I'm going to use summary statistics. We're not going to have to enter in any data, but if you did have to enter in any data, you would just use the edit and then the enter command to edit the data set. All right, this time we're going to do a t-test. The story goes, suppose that the claim is that the average number of M&M candies in a fun-sized bag is 17. In a sample of 15 bags, the average was 16.7 candies, and the standard deviation was 0.9 candies. So we want to test this claim in an alpha of 0.01, and we're going to assume that the distribution of M&Ms is normally distributed. We have to make that assumption because remember, if you have a small sample and you, if you just have a small sample, you have to know it comes from a normal population, or else you can't use the t-test. So we're going to use a t-test, and so we have a small sample and we don't know sigma, we have to use t. So I wrote out my HO and HA, mu equals 17, mu not equal to 17. Next we want to find the test statistic and the p-value. So let me type those in. So mu equals 17. Our sample average was 16.7. SX is our sample standard deviation, which was 0.9. And our sample size is 17. And again, because we have a small sample, we have to use a t-test. And because we don't know sigma. Again, we're doing a two-tail test. So I'm going to select the two-tail test option. And again, ignore the color part. That's not important. And then just hit calculate. So it's giving us our test statistic, which now we can call t, and this should be a lowercase t, just my computer is correcting it for me, is negative 1.374 maybe if you wanted to round to 3 decimal places. And it's negative because our sample average is below our hypothesized average. Let's see, and our p-value, which is just the p number, is 0.188. So we were said to test this at a 1% significance level, alpha being 0.01. So that means our alpha, which is 0.01, is less than our p-value, so same thing as before. And so we're going to fail to reject HO. So there's insufficient evidence that the average number of candies in a bag of M&Ms differs from 17. And by the way, this is completely made up data. All right, example 3. This is actually a real data set. We're asked to do a hypothesis test for proportions. So it says Chance Magazine reported on a study done with 121 volunteers. About half were blindfolded and given a red gummy, and while the other half were given a yellow gummy bear to try. They were asked to guess the color. 97 people out of the 121 guessed it correctly. So we want to test at the 5% significance level if color and taste are related. Well, if color and taste are not related, if they're completely unrelated to each other, then you'd imagine that only 50% of people would guess the color correctly. So if they're not related, that means that the proportion of people that are guessing the color correctly differs from 50%. All right, so let's go over to tests. And now since we're testing a proportion, notice we have p equals instead of mu equals. So since we're doing a proportion, you want to do a 1 prop z test, option 5 on this calculator, and hit enter. 1 proportion z test. P naught is the value that we're saying P is equal to under HO, so that's 0.5. X is the number of successes. Well, we had 97 people guess correctly, and this is out of a total of 121 people. We're doing a two-tailed test, so make sure not equal to is selected, and again, ignore the color part, and then just hit calculate. All right, so our test statistic is 6.64 if you round. And it says the p-value here is 3.23, etc., e negative 11. Okay, remember p-value is just a proportion. So this number has to be between 0 and 1. In other words, you can't have a proportion that is 3.23. That's not possible. So this e to the negative 11 is important. What it means is we need to move the decimal point over 11 spots. So really, instead of saying 3.23, we need to move this decimal point to the left 11 spots. So it's really going to be 0.0000000000, basically 10 zeros, and then 323. In other words, this p-value is really close to 0. So the p-value is approximately that. So you can say it's approximately 0 if you wanted to. This is a very, very small p-value, which means that we definitely want to reject HO. So that's the conclusion. Our alpha value was 5%, which is way bigger than our p-value. So we're going to reject HO and say there's sufficient evidence that there's sufficient evidence to say color and taste are related. That's our HA. Sufficient evidence to conclude, or to support, we could say, that color and taste of gummy bears are related. Okay, and that concludes this video.